In this video we're going to finish the topic of Trigonometry C, and this is the second of two videos on solving equations involving wave functions. So we'll look at the second example, which is in radians this time, and you can also see that there are multiple angles here as well. So we want to solve 2 cos of 2x plus sine of 2x equal to 1 for x lying between 0 and 2 pi. So our solution then, now on the left hand side you can see we've got a sum of different trigonometric functions, so it's desirable to express that as a single trigonometric function, and for this I'm just going to choose k times cos of 2x minus alpha, but you may choose cos of 2x plus alpha or sine of 2x plus or minus alpha. So expanding here using my addition formula, I get k cos of 2x cos of alpha plus k sine of 2x sine of alpha. Equating coefficients then, I can see that k cos of alpha is equal to 2 and k sine of alpha is equal to 1. So I have my simultaneous equations. I can now solve for k. So squaring each equation and then adding will give me k squared times sine squared of alpha plus k squared times cos squared of alpha is equal to 1 plus 4. On the left hand side I've got a common factor of k squared and I can evaluate the right hand side. Now remember, sine squared of alpha plus cos squared of alpha is equal to 1, so I can conclude that k squared is equal to 5 and therefore k is equal to root 5. I can now look at solving for alpha. So k sine of alpha over k cos of alpha is equal to 1 over 2, it's a half. And I can see that my k's will simplify to 1 here, and sine of alpha over cos of alpha is equal to tan of alpha. So that means that tan of alpha is equal to a half. And I need to know which quadrant that alpha will be lying in for the angle. So if I look at the equation involving sine, I can see that's positive, which would either come from the first or the second quadrant. And the equation involving cos is also positive, so will come from the first or the fourth quadrant. So you can see that my final answer there for alpha will come from the first quadrant. So inverse tan of a half is 0.46. So alpha is equal to 0.46. Now I started off on the left hand side of the equation I was given in the question with 2 cos of 2x plus sine of 2x, and I can now express that in the form k cos of 2x minus alpha. So that's root 5 cos of 2x minus 0.46. Now the whole point here is that I'm solving 2 cos of 2x plus sine of 2x equal to 1. So I can rewrite my left hand side of the equation here as root 5 cos of 2x minus 0.46 all equal to 1. And I'm solving between 0 and 2 pi. But I'm going to adjust my range here because I can see that I've got a multiple angle and a phase angle. So multiplying my range by 2 and then subtracting 0.46 will tell me that the angle I'm looking for at the moment has to lie between negative 0.46 and 12.11 approximately. So I can divide throughout by root 5 here, and that will give me cos of 2x minus 0.46 is equal to 1 over root 5. And I know that because cos is positive, my answers are either coming from the first or the fourth quadrant. An inverse cos of 1 over root 5 is equal to 1.11. And then 2 pi minus 1.11 gives me 5.18. So 2x minus 0.46 is equal to 1.11, 5.18. And you can see here the range is much bigger, so I'm going to add 2 pi onto each of these answers. So 7.39 and 11.46. And if I add on again, I would be out with the range. Likewise, if I subtract 2 pi from 5.18, I would be out with the range here as well. I now need to add 0.46 to both sides of this equation to get me 2x being equal to 1.57, 5.64, 7.85 and 11.92, and then dividing throughout by 2 gives me x equal to 0.785, 2.82, 3.925 and 5.96. And if I just have a look at the graph there, So I have drawn the graph of y equals 2 cos 2x plus sine 2x, that's in blue, and in red that's the line y equals 1. And you can see the points of intersection here. There are 4 points of intersection, and the answers that I've got for x are the x-ordinates of these points of intersection. So just now it would be a good idea to pause the video before the screen goes blank and copy this example down in your notes before completing the assigned exercise for today.